Welcome back. In this lesson, we'll discuss the topic of subtraction of fractions. Last lesson, we discussed how whenever you go to add two or more fractions together, one important key thing to remember about the addition of fractions is that you need to have a common base, a common number of slices of a pizza that you happen to be, say, adding together. And this common slice of a pizza or this common base, we refer to it as the common denominator. So if we wanted to, say, add 1/3 with 1/2, because 1/3 has a different denominator than 1/2, we have a special procedure by which we can convert the fraction's denominator to something that would be more in common. And we call this the multiplication by the opposing base method. So you take the first fraction, you don't do anything to it, but you're going to multiply that fraction by the opposing base, in this instance, 2/2. Then you take the second fraction, which would be 1/2, and you multiply that by its opposing base, which is 3/3. And now you have what is effectively a multiplication and then addition problem, because you're going to first multiply across the top and the bottom of your fractions, and then you can do the indicated procedure of addition. So 1 times 2 is 2, 3 times 2 gives you 6, 2 times 3 gives you 6, and 1 times 3 gives you 3. So now you are able to, say, add across the top of your fractions, and you would obtain 5/6. It turns out that the subtraction of fractions is very much the same way. If you have, say, and I'll do a non-trivial example, 4/5 minus 3/4, and you want to know what is this going to be equal to, what you got to do is you've got to keep the original or initial fraction the same. What you're going to do is you're going to multiply on the top and the bottom of the first fraction by its opposing base, whatever that happens to be. In this case, the opposing base for 4/5 would be this 4 down here in the denominator of 3/4. And then I'm going to subtract from this quantity 3/4, but 3/4 needs to be multiplied by its opposing base, which in this instance is 5/5. Okay, so now we just have a more long-winded multiplication problem. 4 times 4 gives you 16. 5 times 4 gives you 20. 4 times 5 gives you 20. 5 times 3 gives you 15. And now you have 16 minus 15 all over 20, which gives you 1/20, which would be an answer. And the correct answer as well. One of the things we should remember, whether we're adding or subtracting fractions, is that you will also need to potentially simplify the fraction that you get at the end of the day, depending on what the numerator and denominator happen to be. Okay, suppose we have 8/7, and we're subtracting from this 4/3. We're asking ourselves, what is this going to be? Well, we're going to take our 8/7 and we will multiply it by its opposing base, which happens to be, in this instance, the 3. And we'll subtract from this the 4/3 that will be multiplied by its opposing base, which will be the 7/7. Now you're going to multiply across the top of both fractions and across the bottom of both fractions. So 8 times 3, well, we do 8, 16, 24. 7 times 3, 7, 14, 21. 4 times 7, 7, 14, 21, 28. And 3 times 7 gives you 21. All right. Again, you're going to do the operation of addition or subtraction across the top. The denominator does not change. So we're going to do 24 minus 28 all over 21. And that's going to give us -4/21. At this point, you have to look to see if you can simplify the fraction. But since 4 does not divide into 21 and 2 doesn't divide into 21, we should be good at this point. One last example that's a little bit perhaps less trivial. Suppose we have -125/13 minus 42 over 15. And the question is, what is this going to be equal to? Well, we're going to need to take our first fraction. We really don't do anything to the first fraction initially, but we're going to write out that we will multiply this fraction by its opposing base, which is the 15. And we're going to do the same thing for the second fraction. So we're going to take 42 over 15 and we'll multiply it by 13 over 13. All right, so we've got quite a bit of multiplication operations to count for, but that's okay. Those are the breaks. It is a math class. 5 times 5 is 25, carry the 2. 5 times 2 is 10, plus 2 gives you 12, carry the 1. 5 times 1 is 5, plus 1 gives you 6, drop a 0. 1 times 5 is 5, 1 times 2 is 2, 1 times 1 is 1. Add everything together, 5 plus 0 is 5, 2 plus 5 is 7, 6 plus 2 is 8, and then you got a 1. So we've got 1875. Note that a negative and a positive is a negative, so it'll be a negative 1875. Now you got to do 13 times 15. 3 times 5 is 15. Carry the 1. 3 times 1 is 3, plus 1 gives you 4. Drop your 0. 1 times 5 is 5. 1 times 1 is 1. Add everything together. You get 5, 9, 1, 195. So this will be negative 1875 over 195 minus 195, because 15 times 13 will be the same thing as 13 times 15. And what do we have on top? We're going to need to go to the side of our page. We're going to do 42 times 13. 3 times 2 is 6. 3 times 4 is 12. Carry the 1. There it goes. Drop a 0. 1 times 2 is 2. 1 times 4 is 4. Add everything together. 6, 4, and 5. So we've got 546. All right. So now we go to the side of our page yet again. We've got 1875. And this is a negative, by the way. So it's like we owe a debt of 1875. And then we owe another 546 to the bank. Or said another way, we started with a debt of 1875 and we lost $546. So if we were to account for all of our liabilities, we've got 1875 plus 546. We're becoming more negative. 5 plus 6 gives you 9. 7 plus 4 gives you, let's see, 11. Carry the 1. 1 plus 8 is 9. 9 plus 5 gives you 14. Carry the 1. 1 plus 1 is 2. So 2419. That will be a negative over 195. Now, at this point, we have to determine whether 195 has any terms that would divide into negative 2419. And it could be possible that 2419 is, in fact, a prime number. However, before we decide whether it's a prime number, what I would tell students to do is just go ahead and find the prime factorization of 195. It's not too difficult. We know that 5 will divide 195 since it ends in a 5. So I'm going to go to the side of my page. 5 into 19 goes 3 times. 3 times 5 is 15. You're going to get 4. Drop your 5 down. 5 into 45 goes 9 times. So it turns out that 5 and 39 gives you 195. Now, 39 should be divisible by 3. And what, 13? 3 and 13? We'll go ahead. 3 into 3 goes 1 time. 1 times 3 is 3. Drop your 9. 3 into 9 goes 3 times. Yes. So 3 times 13 should give you 39. So now to check to see if this fraction can be simplified, all we have to do is check to see whether or not 195, 5, 3, or 13 will in fact divide negative 2419. In fact, we don't even have to see if 195 will divide 2419, because if even one of the factors, one of these prime factors, is able to divide into 2419, that would be sufficient for us to simplify the problem even one step further. So let's go ahead. We're going to go to the side of our page. We've got 2419. We're going to check to see if it divides by 3, because 3 would be the smallest number in this instance, but also because the number ends in a 9, so that might be an indication that 2419 would be a multiple of 3. So 3 goes into 24, let's say 8 times. 8 times 3 gives you 24. Subtract. You're going to get 0. Drop your 1. 3 does not go into 1. any times. So you would say this is a 0, drop your 9. 3 goes into 19, and this is an uneven amount. We're going to get a, let's see, 3 goes into 19 6 times. 6 times 3 gives you 18. And that would be a remainder of 1. So almost very, very close. So it looks like 3 would have gone into 2418, but it just very narrowly does not go into 2419 by only one number, which is a kind of a bummer, frankly, because I thought it might actually divide it evenly. Okay, so we'll try 5 next, and frankly, I don't think it's gonna. The 5 certainly won't divide 2419 because it ends in a 9 and not a 5 or a 0. So 5 is out of the question. Then all we have to do is check whether 13 will divide 2419. So 13 goes into 24 once, and 4 minus 3 gives you 1. 2 minus 1 gives you 1. Drop your 1 down. Now we have to determine how many times 13 goes into 111. So we're going to go to the side of our page, and we're going to try multiplying 13 by a number of numbers because a lot of students probably didn't memorize their 13 times table. So what we're going to do is we're going to try to guess how many times 13 goes into 111 by trying different numbers. So like maybe we try the number 8 because it might be close enough. 8 times 3, 8, 16, 24, right? We'll carry the 2. 8 times 1 is 8 plus 2 gives you 10. So that's 104. And that is, in fact, close enough to 111 that we wouldn't be able to add another set of 13. So it turns out that 13 goes into 111 exactly 8 times. And 8 times 13 gives you 104. So we'll just do that. And by the way, if you accidentally made a mistake here, when you do this subtraction operation, you're going to get a number that's bigger than 13. So always look for that. I know at the moment that's not going to happen here, but if you did happen to do this subtraction for whatever reason, got a number that was bigger than what you were dealing with initially, that would be the reason why. So now we've got 11 minus 4, which should give us 7 on the money. Drop down your, let's see, drop down our 9. So now we're going to think about how many times that 13 goes into 79. Well, 13 goes into 39 3 times, right? And 39 times 2, let's check this out. 2 times 9 gives us 18, carry the 1. 2 times 3 is 6, plus 1 gives us 7. So it looks like 13 should go into 79 exactly 4 times if we're being on point here. So let's check that. 4 times 3 gives you 12. Carry the 1. 4 times 1 gives you 4, plus 1 gives you 5. So that's only 52. Looks like it must go more times. Let's try. Oh, it needs to go 5 times. 5 times 3 is 15. Carry the 1. 5 times 1 is 5, plus 1 gives you 6. That was 65. And then we can try. We'll do 13 times 6. 6 times 3 gives you 18. Carry the 1. 6 times 1 is 6, plus 1 gives you 7. So indeed, okay, here we are. So it would turn out that 13 goes into 79 exactly 6 times. And unfortunately, here again, we're going to get a 1 as a remainder. So that's really, really a bummer. We're so close to being able to divide 2419, and it does make me suspect that 2419 is likely to be a prime number. However, regardless of the case, all we can say now for sure is that this number will not simplify because no prime factor of 195 will divide 2419. And so we would say we have the answer at this moment.